Imagine we are dealing with machines. Now, this machine, when we buy it initially, we have what we call our first cost, and we operate it and maintain it, so we have an operating and maintenance cost. And during its lifespan, we will replace it. It can have a salvage value. Sometimes it doesn't. And of course, we have a replacement cost. These factors are what we need in order to discuss our next lesson. We call that the capitalized cost. Now, I have here a typical cash flow diagram of a machine or an item. Now, for our first year, when we buy that item, we initiate buying it. We have here our first cost. And during the succeeding years, during its operational life, we have here what we call the operating and maintenance cost. At the end of the lifespan of that item, of that product, we can sell it for a salvage value. And of course, if we want to continue using it, we need to replace it. So we have here our replacement cost. Now, in order to make sense of it, imagine that the cost of money is I. Well, that is our interest rate. And if we take the present worth of all these values, we have here FC, that is already the present cost, plus, now we have an operating cost that is assumed to be infinite. After we replace it, we will still have that operating cost after replacement. So that is infinite. It's a perpetuity. So the present worth of a perpetuity is the annual cost over the interest rate, the cost of money, plus, now, during the end of the lifespan of the item, we have here our salvage value and replacement cost. So in terms of cost, that is replacement cost minus salvage value, and we take the present worth of these two, so we divide it by 1 plus I raised to n minus 1. This expression is what we call our capitalized cost. So this is the capitalized cost. Let's say K. Let's represent the capitalized cost as letter K. So, okay, so that's the capitalized cost. Let's have an example. Imagine we have a machine that is worth $300,000 and its lifespan is 15 years. Now, we have an annual maintenance for that machine which is equivalent to $5,000, and if the worth of money or the interest rate is 5% and the salvage value is 50,000, we are being asked what is the capitalized cost. So we will use this formula for our capitalized cost. If you can see in our data, the replacement cost is not given. When the replacement cost is not given, it's implied that the first cost is also the replacement cost. So it makes sense because when you replace it, you buy another machine just like the original one. So that is the replacement cost. Going here, here's our formula. We simply substitute. The first cost is 300,000. The operating or annual maintenance cost is 5,000. Our cost of money is 0.05 or 5%. And if you go here, this is our replacement cost. As I said, it's also equivalent to the first cost. minus the salvage value of 50,000 over 1 plus the interest rate raised to n, which is 15 years, as given here in our data, 15 years, minus 1. If you compute this and add it up, you will get 631,711.44, or this is approximately, that's about $632,000. So what does it mean? The capitalized cost simply means how much capital or how much money you should invest in order to sustain your original machine. So you need to invest this much so you can always have the machine working. You can replace it and you can maintain it just perpetually, continuously, as long as you invest this money at the rate of 5%. So that is one example of capitalized cost. Annual cost. Annual cost is defined as the sum of three values: the annual interest on investment, the annual operation and maintenance, plus the annual depreciation cost. Now, it's easier if you just remember that the annual cost is equal to the capitalized cost times I. Therefore, it follows that the formula for annual cost is equal to first cost times I plus operating maintenance cost plus the replacement cost minus salvage value times I over 1 plus I raised to n minus 1.